Now we will move on to some simultaneous equations. I'm sure that you're probably familiar with equations that are a system of linear equations, something like this. And then what you do is you double that bottom one, and then you would subtract, and this is called elimination. But say if you got the something like this, it's a little bit harder to isolate some of those variables and get rid of them. So this is why we would go back to something called substitution. In this situation, we would do that's equal to 6 minus x, and y equals 6 minus x over 4, and then we'd substitute that into the equation. And then we would solve. Because now we only have one variable, so we can solve it normally. And then after we get that x, we would substitute it back into one of the equations to also get the y, and then we'd have it solved. Additionally, and that's one way you can do it, but sometimes, and this is quite common, that you might get just the two equations on the graph. And then you just have to solve it. You would make them equal because both are y, and then solve that. And this is also another example of elimination, because if you were to subtract the two away from each other, you'd get rid of the y, which is the same as the elimination, which you quite use often with the system of linear equations. And then you'd use either quadratic formula completing the square, or factorization, depending on what works. And I'm sure you know that once you get the x, you would substitute that back in to get y. We can do another example. So let's take these equations here. We can say that y is equal to 12 over x. That x minus 4 times 12 over x equals 2. X minus 48 over x equals 2. We can multiply all sides by x. Rearrange. And then factorize. And you may get more than one solution for x, so you need to evaluate the y separately. So y equals 12 over x equals 12 over 8, or y equals 12 over minus 6, root of minus 2, or that would be 3 over 2. And if it and potentially it could ask this question in the form of, okay, we've given you these two equations of graphs, find the points of intersection. So you have to say intersections at 8, 3 over 2. Make sure you get the right ones together, and minus 6, minus 2. And, there are a whole raft of things it could ask you, but generally it'll give you one linear and one non-linear. So one that's just got nothing more than the power of 1 for variables, but the other one might have some more. Generally, only the highest power is 2, though. And you'll have to figure that out. Now, like I'm doing with a lot of these things in quadratics, I'm not going to spend a whole lot of time doing lots of questions, because I'll save those will be in other videos that I will do later on. for now, I'm just explaining what these really are. And if I just reiterate and re-explain what simultaneous equations actually figure out is on a graph, say you've got, what's this, x, y equals 12, so y equals 12 over x. It's a bit like this a little bit. Roughly like that. And suddenly we're chucking in x minus 4y equals 2. So what's that? X minus 2. It's going like that. Should have a positive gradient, sorry. Equations. We're saying we're trying to figure out when do these things equal each other. So the best, the easiest, the most free way is when they both equal the same thing. You can just set them to equal each other and then rearrange and solve. But if that fails, perhaps you need to rearrange one of them to get one of the variables alone in terms of the other one, then substitute it back in, and then you can solve for that one and then solve for the other one, if that makes sense. And then if you've got two linear ones, you would do something called elimination. You multiply together, so you get that. Notice you've got that 4x, and then you could just subtract all of this. And then you have to substitute this back in. So 2x will equal 17 minus 3 times 5 equals 2, x equals 1. I'm actually quite surprised I managed to get whole numbers for that when I just made it up on the spot, but anyway. So yeah, that's pretty much what simultaneous equations actually is. You got to imagine, okay, we put these two equations on the graph and we're trying to figure out where they meet. Anyway, so I think this will make sense, and this is an explanation, and it is obviously going to make a lot more sense with the more demonstrations of questions that are done, and you will get to see those in later videos.